All right, so if everyone could take their seats, we're going to start with the next session. So I am Erica Miller, and I am the viticulturist for the Stoller Wine Group. I also counted berries for Patty in her last talk. So this next session is demystifying nutrient management, putting numbers to your nutrition plan. I have two beautiful gentlemen right over here, Paul Schreiner and Russell Moss. Paul Schreiner is the plant physiologist at the USDA Agricultural Research Service. He has a bachelor's degree in biochemistry and a PhD in plant physiology. Both are from Penn State University. He's worked on grapevine roots, mycorrhizal associations, and nutrient physiology for the past 20 years. And I'll also introduce Russell right now. Russell is a lecturer in viticulture at Cornell University. He has a bachelor's degree in viticulture and enology from Lincoln University in New Zealand. And he also has two master's degrees from Virginia Tech, one in viticulture and one in enology. Russell also has managed a lot of vineyards, both in New Zealand and in Oregon. So first up, we have Paul Schreiner.
Do you know where my talk is? Oh, there it is. Okay, good. Thank you, Bree. Good morning, everyone, or actually, yeah, it's still morning. So the idea of this session was to give you some numbers and talk a little bit about how to go about doing some tissue testing. So let's just get started. And I'm going to have to go through this pretty quick because we've got only 45 minutes for both me and Russell to talk. So find me at lunchtime. And we also know that we stand between you and lunch. So we're going to try to go fast. So let's roll. All right, if you've ever seen my talks before, you've seen this slide. This is the way I look at nutrient management. Hopefully some of you do as well. There's 4 parts in my mind. One is scouting. Scouting always has to be part of your management, in my view. Back to Patty's old expression, boots on the ground. Very valuable. You got to know your vineyards, and you can't tell it from your pickup truck. All right, the other part is routine analysis. You see I've got leaf highlighted there, and I'm going to talk about that a little bit more. These are leaf and petiole tests, right? I'm not saying you have to do them every year, but maybe every couple years is a good idea. If you got a lot of money to spend, I'd do them every year. Also note, I've got soil testing question mark there, and I'll briefly talk about that. The third part about nutrient testing that I think about is what I call targeted sampling. That's when you're actually trying to diagnose a problem. I'm not going to talk about that today, but if you want to learn more about that, come talk to me. And then finally, the last thing is, based on this information, you're going to alter nutrient supply to the vines. And of course, that's going to feed back up to the other aspects that we look at. All right, so this idea about soil testing. Is soil fertility a good predictor of grapevine nutrient status? Well, I have some data on this, and this dates back to the very first project I did on grapevines in Western Oregon. We surveyed 29 own-rooted vineyards, and this is just basically the soil test values and then leaf test values from those vineyards, and this is just the range of values, and then on the far right column is the correlation. And you can see it's not very good. In fact, some of them are negative. The one I've got highlighted there on the top, nitrogen, was the one that was the closest, but even that was not significant. So, short answer to that question, no. So, a brief history on tissue testing, because I think this is helpful to understand where we've come from. So basically, the French were the first to do this. They did it back in the 1920s. They used whole leaf blades. They sampled 4 times during the season. And then they collected data. And since that time, basically Europe uses leaf blades. Well, in the US, we have to be different. So in California, work in the 40s really focused on petioles, mainly looking at nitrogen and potassium. And that work kind of got extended into Australia. It also got done in New York. And then petioles became widely adopted in the United States. However, numerous physiologists, myself included, have often questioned this reliance on petioles. And it's interesting when you go back and look at the old papers because they're really not that good. You know, we did science different back in the 1940s and 50s. And so the way that people evaluated was a little bit more biased. Okay, so I wanted to test this idea. What's better, leaf blade or petiole, in doing nutrient diagnosis? And so this data comes from my pot and pot vineyard for the most part, which I'm going to talk a little bit more about in the second section of my talk as well. But basically, we did something very simple. We collected leaves and petioles at bloom and veraison, and then we used the raw data. So experimental plot data, not mean data. So I'm not inflating my R squares here. And then we looked at how well those values predicted vine responses to nutrients. And the reason I did that is because I had a system where we actually had vine responses to nutrients, which is from my pot and pot trial. Okay, so the results of that are really pretty straightforward. I'm just going to show a few pictures. This is predicting prune weight based on either leaf blade nitrogen in green or the petiole shown here in blue. And you can see pretty clearly R square is a lot better with leaf blade. Predicting yield, same thing. R square is a lot better with leaf blade. Oops. Mustian, guess what? R squared is better than with leaf blade. So this gets, pretty boring pretty fast. I had also one data set where we had enough data from commercial sites, and that was based on YAN. And the same story here. Leaf blade is better than petiole at predicting YAN from our commercial sites. Okay, so this story is pretty simple. Leaf blade's better, okay? I don't have time to go into it today, but the biggest reason we had the variance in petiole was because of year effects. For some reason, it moves around over years where leaf blades did not do that so much. And of course, you could also tell by the data, we have a much smaller range of petiole values. So of course, that also explains some of this. Now, I didn't show you the phosphorus and potassium data from that experiment, but basically the take home from that was both were about equally good, at least based on that regression analysis. So given all that, I say blades are better because nitrogen is so important to monitor. And we didn't see a difference with phosphorus and potassium. And I want to make one more point here, and that is that when I get called out to look at issues, try to help people diagnose nutrition problems, leaf blade always is better than petiole at diagnosing that problem. And I'm not going to go into details about that, but you just have to take my word for it. So this is the numbers part of the game here today. This is what you all came to the session for, if you read the description. So I want you all to memorize this, and you got about 30 seconds. 2, 3, no. If you want this, email me. If you don't have it, email me and I'll send it to you. Basically, I have NP and K kind of highlighted here. I just talked a little bit about that. That's because I've done extensive work on that. I'm a lot more confident about those numbers. So those numbers I feel really good about. Again, these are guidelines. They're not concrete numbers. But I wanted to make one more point with this slide, and that is with regards to magnesium. I've had enough call-outs and looked at this enough times to know that that's actually too high. I haven't changed it yet because I want more confirmation before I make the change. So I try to be pretty conservative with this table so that we're not recommending things until we have a lot more proof. And I also incorporate findings from other places when I think about the numbers that go into this table. All right, so now what I'd like to do is talk a little bit about where those numbers came from for NPK. And most of you hopefully know about this work that I've been doing in the pot and pot system. I was really surprised because I just found out last week that this won the Best Viticulture Paper Award for last year from the American Society of Enology and Viticulture. Good for me. While that's good for me, it's also good for you because it's advertising for Oregon. Who do I work for? I work for Oregon. And nationally. I'm ARIS. Anyway, I just want to give a background on where these numbers came from. So this data on this slide is showing the bloom leaf nitrogen and the veraison leaf nitrogen over time in this trial. And at the first year of this trial, 2011, vines that were 3 years old, they carried their first crop, and we did not manipulate anything yet. So it starts in 2012. And basically all I'm showing here is that we did what we wanted to do. We wanted to manipulate nitrogen supply, and we did. And I wanted to show, in the last year, you'll see on some of these slides, this new line where it's dotted and it's black. I decided to return that lowest nitrogen rate in 2015 back to the high rate, just to see how well vines responded. So basically, this is what we wanted to do. So what was the effect? Well, here's the impact on prune weights on the top, and then yields on the bottom. You can see pretty clearly that we affect prune weights with nitrogen a lot more than we affect yield. That's a good thing, because that means growers in Western Oregon who have too much vigor can use nitrogen to draw the vigor down and not reduce yields. Okay, given the caveat, these vines are thinned to kind of what I would consider industry standard practice. I've got the middle nitrogen rate highlighted there because you can see we are really controlling prune weights a lot with that middle nitrogen level, but if you look at the bottom graph, we never affected yield. Now here's some data for the effects on the must. We did have a tiny effect 1 year on bricks, but it was actually kind of unexplainable and never reproduced, so I don't think it's too critical. The other thing, of course, we did was we affected juice yans. Everybody's interested in yans, or at least many of you are interested in yans. And again, I've got the middle nitrogen thing highlighted here. And the reason for that is because if you look at that, we are pretty consistently hitting 100 yan. And in a lot of people's minds, that's too little yan, right? Well, of course, we looked at that, along with James Osborne at OSU. We did these microscale ferments from fruit from this trial. And very quickly, here is all the data of the nitrogen replicates over the different years of this trial. And you can see pretty clearly, we're not really starting to affect the time it takes to finish ferment, or we're not influencing the fermentation rate until yans are about 100. So I recommended in that paper, along with James, that 100 is probably a more appropriate number for Pinot Noir than what the industry standard of 140 is. And of course, some people even want 200. So hopefully this will get some traction with winemakers. I'm not sure. Because reducing yans are a good thing in some ways, because it's also going to reduce potential spoilage events later. And of course, it also means you can reduce nitrogen use in the vineyard. Okay, I'm not going to go through all this data because it would take until after lunch. But we also worked on wine aromas on this trial. And just a quick summary of that, nitrogen had a massive impact on wine aroma. It was really big. And the way that it affected wine aroma was mainly affecting the yeast-derived volatiles, not the stuff that's already in the berries. And basically, it flipped the ratio between branched chain and straight chain esters and alcohols. And the branched chain ones actually tend to have lower threshold values. The other thing that was very interesting was our, what we would call the bad sulfur compounds, the volatile thiols that give the bad rotten egg sort of aromas. those actually went up as nitrogen went up. Most winemakers will argue that they want lower YAN because they're worried about sulfides. Our data was completely opposite of that. I have no good explanation for that right now, but at least with Pinot Noir, it appears that this is not a big risk. So I came up with this kind of way to summarize this data for nitrogen. So what I've got here is sort of like a thermometer. This is leaf nitrogen, and I'm using veraison. If you look at the very bottom there, when it's coldest or when nitrogen is lowest, we actually can affect yield when nitrogen is 1.5% in a single year. So that's a useful thing to know. As you go a little higher in nitrogen, get to 1.6%, we started to affect some things, including fruit set, some photosynthesis data was sometimes affected, but this was never consistent across years. Moving up, when you hit 1.7 is where we consistently reduced yield in Pinot Noir. And so the next level up at 1.8 is about where we're at 100 YAN. And then finally, somewhere above 2 is where we're going to hit a YAN of 140, which is the kind of industry standard, right? So my values, I'm calling 1.8 the critical value, so that's the value that's in that table that you can get from me. And then I'm calling that the safe value. So that gives you some idea where these numbers came from. And I think I have enough time here to go over quickly, thank you, the phosphorus and potassium part of this story. So the phosphorus part of this story is actually pretty simple, so I can go through this pretty quickly. This is a photograph of my pot and pot trial in the 4th year of vines that had been getting no phosphorus for 4 years in a system where the root system's confined. They don't look so bad. So again, like I did with nitrogen, I have these graphs. I thought about this over and over. This is the easiest way I could figure out to present this data. So again, this is what we were wanting to do, manipulate phosphorus supply and then see how it affected vine performance. These are bloom leaf pea on the top, veraison leaf pea on the bottom, and the control is the black line, just like the nitrogen, and then our lowering rates of phosphorus. And you can see that we did what we wanted, just like with nitrogen. So that part of the experiment worked. You can also tell from this how much more responsive or how much bigger the differences are at veraison as compared to bloom with phosphorus. So now what happened to the vines? Well, basically it took 3 years of getting no phosphorus to affect yield or affect vegetative growth. And they both were affected at the same time. So only in our no P treatment did we ever reduce yield or growth. And so we also looked at fermentation. This was actually the first time this has ever been done well with red winemaking, believe it or not. We got down to a phosphorus level of 30 in our musts, and we did not have any influence on fermentation rate. So we were already reducing yield, reducing growth, before we had any impact on fermentation. So we know that our must P levels don't need to be that high in terms of yeast health. Of course, we also looked at effects on aroma. We got a few minor effects, like 1 or 2 things were usually affected every year. You know, I'm talking about 50 or 60 compounds. So I mean, just by chance, some things are going to be different by year. But we never had the same thing happen twice with phosphorus. So I don't think phosphorus really has a big impact on wine quality or wine aroma. So it's really a viticulture issue. And surprisingly, based on the literature, I was really expecting to see effects on flowering and on fruit set, because that's what's published regarding phosphorus limitation, but we never saw that. And we saw basically no influence on wine's secondary metabolites. So this one's really easy, no need for a little thermometer guide. When veraison leaf blade P is 0.1%, that's when you limit yield or growth. And so because that's a fairly low value, I'd say When your values are getting to 1.2 or 0.12, sorry, at veraison, that's about the time you want to keep an eye on phosphorus. Okay, so potassium, I'll do this pretty quickly too. So these are potassium vines, again, 4 years after getting no potassium supply. I don't know if you can see that. I can't see those very well, but you can see some of those leaves don't look too good. But the canopy is still pretty big. And so again, like I did with the other two nutrients, same kind of plots here showing our impact on us manipulating potassium, how that would affect vine potassium status. Well, we did what we wanted. It's pretty clear here what's going on. So how did this affect growth and yield? Well, with potassium, it took 4 years with no potassium before we actually affected either prune weights or yield. However, the big deal with potassium, and most of you probably know this, was we started to affect must pH. And it started getting a little too low. So the cases where I have the star there is where it significantly differs from the control. And basically you can see when you compare that to veraison leaf potassium level, it's pretty clear where we're affecting must pH. And that occurs when leaf K is at 0.5%. That's a pretty low value. Of course, the other thing that happened with low potassium was we induced late bunch stem necrosis. Fortunately, this happened at a slightly lower potassium level than where we were affecting pH. Again, looking at fermentation, no impact on fermentation, with varying must potassium. And also, the volatiles, in this case, there were a few effects, but again, not super consistent. And the other thing I think is that most of those effects were really probably driven by the pH effect. So as far as potassium goes, here's our guide for potassium based on veraison leaf potassium levels. You can see when veraison leaf potassium is around 0.4%, that's when we were affecting prune weights. We actually did reduce sugar accumulation 1 year. We also see leaf symptoms at that level. As you go up a little bit higher to 0.5%, which I showed that data, that's where we affect must pH. And so my proposed critical value is a little bit higher than that because I don't want to be risky with potassium. And somewhere, I don't know where, above 0.8%, it could be as high as 1.2%, we're probably getting too much potassium and we're going to start boosting pH too high in our musts or our wines. So that's kind of our summary values of that's why I chose these values. 0.6 as critical, 0.7 as safe. And then I just want to give a brief introduction here to our next speaker, Russ. We did some work a long time ago, along with Jessica Cortell's PhD project, looking at spatial variability. And I just want to say that project taught me a lot. And the thing it taught me was do a pot and pot trial. Because I do all these trials in these vineyards, and nothing would end up being different because the variability kicked our ass. So variability is another thing you have to deal with in how you manage nutrition. And so Russ is going to talk about that, and I'll invite him up to do that now.
All right, it feels really good to be home, really good. I just wanted to say, I want to embarrass Paul a little bit here for a second. So I was on the committee for the Best Paper Award for ASCV, and that was the quickest committee meeting I've ever been in. It was about a 5-minute meeting, and it just basically went, "It's Paul, right?" Everyone said, "Yep, unanimous." So thank you, Paul, for your work. That was really awesome, and I'm only slightly mad at you for calling into question some of my master's work. Okay, so I want to talk about functional soil mapping. Someone called this precision soil mapping. I don't really like the the term precision ag, I don't think there's very much precision in agriculture in general, and also I think precision agriculture to me just can I have some sort of negative connotations with that terminology. So I call this functional soil mapping, and you'll see what I'm talking about. In the past, I've had soil maps that have been sort of, names of soil types or something on the farm, but I can't really do much with a name. I need to know what's actually happening on the farm with that soil in terms of chemical and physical properties. So we're going to talk a little bit about precision ag. It's just the use of sensors and geospatial techniques to zone in on your farm and to support your decisions. Most of us that have been doing this have been using it for sort of zonal management. The most common technique that we've been using, I think, as an industry really has been zonal harvesting, which is quite easy to implement and easy to see the cost benefit of that. Some of us have also been using it for variable rate fertilization, and that's certainly gaining more popularity globally, especially in areas where you have to put nitrogen on the ground. Cover cropping as well is something that people have been doing, so variable rate seeding and cover crops or different kind of cover crops, so using cover crops that will compete more for water and nutrients in higher vigor zones, and then cover crops in zone like buckwheat or something that doesn't really compete for water and nutrients in lower vigor areas. Obviously cultivation. Maturity sampling is one it's fairly interesting, and that's something that happened at Cornell. They developed an algorithm where you can go out into the vineyard and basically walk 200 feet in a block and then take samples within that 200 feet, and then you'll capture the total variation in your entire block. That's an algorithm which Gallo, I believe, funded that research, and now they use that for their sampling in the Central Valley. I think they also use it in the North Coast, and it saved them tens of thousands of dollars in sampling costs alone just last year. And that's an algorithm which you can actually license from Cornell if you want. And then also coming soon, people are developing ways of doing variable rate spraying. So do it like turning up your water volume in the higher vigor zones, getting better coverage, and then turning your water down in the lower vigor areas. So my experience with precision ag is I pay a lot of money, I get a bunch of data, and then I don't know what to do with it. So it's kind of turned me off to it, but I still am always searching for ways to understand the variability on the farm, because the variability in farming is the bane of my existence as a manager. So I want to talk about what we did at Schmecketa Community College, and this technique I've used off and on for the last 7 years, both in California and in Oregon on multiple properties. But unfortunately, I can't use the data from the other commercial sites. But I can use Schmecketa because they're lovely people. So this is the Schmecketa vineyard. It's a teaching vineyard. It's 8 acres. It's your typical Oregon mix of sort of moderate vigor, moderate to low vigor scions and moderate to low vigor rootstocks, with the exception of a little bit of Sauvignon Blanc and Tempranillo in the western portion of the vineyard. So just a quick refresher if you haven't been using NDVI. It stands for Normalized Difference Vegetation Index, and it's really just kind of a measure of how healthy your plants are, really how much chlorophyll you have relative to plant size. And so what it is it measures reflectance of near-infrared and red, and then runs it through this ratio. The red is, so chlorophyll has 2 absorption maxima. One's in the blue and one's in the red. And as you get more chlorophyll in the leaf, it absorbs more and reflects less red. And then the near-infrared is just accounting for all the other stuff that's not chlorophyll. So it's really just accounting for plant size. So I want to show you a few things. This is something I've been working on for the last few months, getting myself actually familiar with how to use GIS and deal with satellite data. But this is on the left-hand side of that slide. You see an NDVI done from manned aircraft on July 11th, 2018. And generally, for my purposes, I only need one good image at full canopy. I really don't care about the rest of the season. I just need one image to do zonal management. And so I generally shoot for images in July, kind of mid to late July. And Then on the right, you can see an image that I created from Sentinel-2, which is a European Space Agency satellite, and you can do this for free. This data is available for free. It's obviously a coarser resolution, but I think for commercial applications and for really what we're trying to do with zonal management, I actually think it's probably fine for most things we're doing in the vineyard. But you can still see the trends are roughly the same. By the way, the color scale is sort of the greener stuff is kind of lower vigor, and the bluer stuff is the higher vigor. Here's if I zoom out to a larger commercial vineyard. Here's a comparison with a vineyard in Sonoma, and again, you can see there's pretty much very little difference on a practical level between these images when we're talking about zonal management. And that's again, it's a free image. You can create these yourselves. Oh, and by the way, I will set up in terms of creating these yourselves. It took me a while to figure out how to do this, but once I did, it's quite easy. And I'm incorporating this stuff into my courses at Cornell. And I'm also going to create a website with video tutorials. It'll be membership based, but people with an @shemeketa.edu email address will be able to access it. Okay, and then here's another comparison. Again, this is manned aircraft versus Worldview satellite, and Worldview is a satellite that was developed by a company called Digital Scope, or Digital Globe, rather. The Worldview satellite image, it cost 4 cents per acre, but you do have to purchase 6,100 acre swath, so it cost me $300 for the image. But really, I think it's worthwhile, and especially if you get together with neighbors, and you all just pitch in, it ends up being quite cheap. And you can see at that 1.85 meter resolution, it looks pretty much identical to the manned aircraft. I should also mention Worldview passes over once every day. So if you wanted to, you could get daily NDVIs, go nuts. And then the Sentinel-2 is every 5 days. So just a quick refresher on why we're looking at vigor and what matters about vigor. Of course, higher vigor vines, you get more occlusion with leaf layer, and so you can end up having higher disease pressure because you have less fungicides entering your fruit zone and less airflow and sunlight. Also less color and mouthfeel because of that occlusion and that lack of light. And also more green aromas, which is partially due to leaf layer occlusion. There's also work from Cornell, from Gavin Sachs and Justin Shiner, that shows that methoxypyrazines may actually develop independent of leaf occlusion, but actually as a function of vigor itself. So even if you get rid of the leaves, you can still end up with more methoxypyrazines in those high vigor vines. And less varietal aroma, and slower ripening. And then sometimes in the higher vigor zones, and generally on the West Coast, I find that in the higher vigor zones we have higher yields. On the East Coast, that's different because we have such high vigor that we get lower yields in the high vigor zones because we get so much bud shading. So I had my students at Shemeketa go out and collect data to look at variability in the vineyard. So we took the Pinot Gris block, which is sort of the large, what we'd consider sort of the production block at Shemeketa, and we broke it up into high vigor and a moderate vigor zone. The high vigor is incredibly high vigor. There's a patch so that you can see the little patch in the eastern part of that block where it's such high vigor that more line posts had to be put in there because the canopy kept falling over. So you can see that the cane weights in the higher vigor stuff, it's about twice the weight as the lower vigor. And then I had them go out and take primary chemistry as well. We ran stats on these, and everything comes out statistically significantly different, but really from a practical level, they're not that different. So we wouldn't necessarily separate this based on bricks. So moderate vigor, 20.9, and high vigor, 21.2. pH is kind of the same. Again, it's a significant difference, but not that different. And this is generally kind of the trend that we see between higher vigor and low vigor, right? So it's the higher vigor stuff, the ripening is slower. The TA is really where it breaks out and to a significant difference on a practical level. So it's 6.9 in the moderate vigor and then 7.8 in the high vigor. Okay, so now what we want to do is figure out what's actually causing the variability in this growth. So I had them go out and take soil samples, and really you can see in these graphs, there's not much difference in the soil samples, so there's really nothing we can manage to, right? It's just, it is what it is. So this is where the mapping comes in. So we use a system called Trimble Soil Information Systems, or Trimble SIS. I should mention I'm not getting paid by Trimble, or I have no association with any of these companies. I just think it's an interesting tool. And it's just it's a combo of sensors and software, and it produces three-dimensional maps of your soils. The cost is about $200 an acre. So really, honestly, it's not that much, and mostly I use this at development to figure out development, and then we can use these maps going forward. So it's a one-time cost, and that's pretty much it. And they can do this thing incredibly quickly. So they can cover about 30 to 40 acres per day, and then get your maps to you within about a week. So this is how it works. And I'll go through each of these processes, but first they go through with an EC sled, electrical connectivity sled. Then they go through with a fancy penetrometer, take some soil cores, process it. Ooh, quick, okay. Here's the EC sled. It just measures electrical conductivity spatially across your farm. And EC correlates to a lot of different things, and in and of itself, EC is worthless. So because it just correlates to so many different things. So here it is. You can see EC maps. That looks pretty. Again, there's not much value in that in and of itself. But it's useful in the Trimble algorithms. So the Trimble algorithms will then tell you based on that EC map, it'll tell you to go to various parts on your farm and take these penetrometer readings. The penetrometer measures tip force going into the soil, and then friction down the sleeves, relative water content, and it'll map that out as well. This is kind of what it looks like, but again, this doesn't matter. It's again just sort of a relative measurement that is useless in and of itself, but the Trimble algorithm will then take this and the EC data to tell you where to go take soil cores. So then you go out and take the soil cores based on the sled data and the penetrometer data, because what that's doing is now telling you where there are zones of similarity on your farm. And then you take it at depths of 1 to 2 feet and then 2 to 4 feet. So you can get sort of topsoil and subsoil measurements. So here on the Schmeketa farm, we did 8 cores. So you take about 1 to 1.5 cores per acre, roughly. If you do this, also I should mention, you should go out with them and do it, because there's going to be areas that the system will miss that you might be interested in. And so you can have those added into your data set. So then it processes it and puts it into PDFs and georeferenced files, which you can deal with. You get about 76 different maps. There's only a few that I think are very useful, and I'll show you what those are. So let's look at the manned aircraft again. There's our high vigor zones. So I pulled those out with polygons. Here's nitrates. There's high vigor zones over nitrates. And you can see they line up very well. I will be running spatial analyses and stats on these as well. But I have to get through the spatial analysis course at Cornell first. So here's plant available water. You can see it lines up quite well. And then organic matter, which is, of course, kind of combining both things, because organic matter is really a sponge for water, but it also has it's a large pool of mineralizable nitrogen. And again, lining up with the high vigor zones. So the next step is to model this out and correlate these with the NDVI with soil data, but also start to use undervine cover crops to pull that vigor out in the high vigor zones, because that'll compete for water and nitrogen. And then do some zonal tissue sampling and modeling with that with the students. And then possibly variable rate fertilization, even though really at Schmeketa, we don't need to put nitrogen on that soil. But variable rate does work. This is a paper from 2018 in the journal, where they showed decreasing variability in the vineyard by using variable rate nitrogen fertilization. But other uses, and these are really what I use it for, is block design. So go out before you even put the vineyard in the ground, map it out, look at your nitrogen, plant available water, and organic matter, and then that's where you decide how to design your blocks to minimize variability. Also, yeah, variable rate fertilization, putting in drain tile, and I have used it to do some variable rate spacing as well. We'll see how that works out in the next 8 to 10 years. Just want to make some acknowledgments. So the team at Shemakata, my friends Jesse, Scott, and Rob, they've all been incredibly supportive of me. Also all of our students who helped us do this. By the way, I'm in that photo, and I'm not going to tell you where. It's really embarrassing. Tyler Ulrig at SciTech, and Terry Avion for donating NDVIs to Shemakata. Thank you very much. Karen Peterson, I talked to her yesterday. She wishes she could be here, and she misses everyone a lot. Thank you.
So we'll just take a small amount of time for anyone's questions that they have. Oh, Patty.
So I don't have a question as much as I just want to mention that table that Paul said you should memorize. You might have forgotten that we had put an article on the Extension website. If you go to extension.oregonstate.edu and type in vineyard nutrition or vineyard management, it'll pop up an article that has that table in it. So it's online.
Cool. Thank you, Patty. Go ahead.
So the question was, using that GIS data, if it's useful, or if you can use it across all platforms. Yeah, so I use QGIS because I'm incredibly cheap. Even though I obviously I'm at Cornell now, so I have access to ARC. But ARC is very expensive, and I think prohibitively expensive for most vineyard operations. So I'm teaching my students QGIS as they go forward. So I'm only using data that I can use in QGIS easily. And yeah, like, you know me, I'm a dummy, and so it's quite easy for me. So I think it'll be simple for you.
All right, so I guess we are going to hit up lunch now. So thank you guys.